I'm going to just zip through connecting validity to reliability right now. Hello. We're going to connect validity to reliability. I know I just said that. Okay, so remember, the standard error of measurement estimates how repeated measures of a person on the same instrument tend to be distributed around their true score. And that true scores, frankly, are always unknown because no measure can be constructed that provides a perfect reflection of true score. It just doesn't happen. You can even see like self-reported, like measures of height still have standard error of measurement. Part of that is because humans lie, but you know, there are other reasons too. Oops. Okay, so now let's talk about how these connect. So, or I lied. So here is an equation for standard error of measurement. We can see that it is the difference between our estimated score and true score. And we can calculate this by finding the standard deviation of the test and multiply that by the square root of that little piece of that chunk. This should look very, very similar to what you learned in regression. But essentially, it's showing us how much variability is around our estimate as a function of measurement error. And related to that is this idea called maximum validity. Because maximum validity depends on reliability. It sets the ceiling for how high a correlation you can expect with anything. And here's how you do it. What you do is you take the square root of the reliability of test 1 with the reliability of test 2. That is the maximum, because what you're doing is seeing the maximum amount of variability that could be explained by your test while you, sorry, I just had a brain fart. Let's back up. Okay, so you're seeing what the ceiling is, because everything above that correlation, everything above your maximum is impossible, because you can't correlate, uncorrelate, or random error with random error. What you are doing is explaining the total amount of variance explained between your two tests. That is the maximum amount that you can predict. So if you have a perfectly reliable test, 1, and a perfectly reliable criterion, your maximum is 1. However, say you have a perfectly reliable criterion, but your test reliability is 0.8. Then your maximum correlation is the square root of 1 times the square root, or square root all of it, by 8. So that is 0.89. That is your maximum. So if you have one perfect measure and one pretty good measure, your maximum correlation that is possible is 0.9. There's a little less than 0.9. And if one of your measures is totally unreliable, you can't predict shit. So I've produced a table here to kind of help you wrap your minds around this idea. So think about it deeply, because essentially reliability is the limiter for validity. If you do not have a reliable test, you can't have a valid one, because there's no way to demonstrate it. So that's it. I'll see you all later. Bye!